Artificial intelligence platforms promise to map connections and test hypotheses at speeds that outpace human cognition. They offer a vision of light-speed human-machine synthesis. Beneath that speed, however, is a restrictive architecture. These systems function as a filter on human discovery. Scientific orthodoxy isn't created solely by an authority declaring certain claims to be true. It is formed by controlling the underlying conditions under which new claims can be developed. The platform manipulates these conditions by introducing epistemic friction. It changes the cost of exploring a thought, determining which ideas survive to become legitimate science. To suppress novel research, these platforms do not need to rely on explicit censorship or maintain lists of forbidden ideas. Instead, they rely on friction. The platform makes one kind of inquiry cheap to pursue and another administratively prohibitive. Easily classified research flows smoothly. But for open-ended inquiry, the platform adds procedural requirements, making the work difficult to sustain. Over time, this unequal distribution of friction dictates the survival of ideas. It shapes which methods become the standard and which forms of knowledge eventually acquire authority. Every research project usually starts with a productive phase. You are engaged in a free-flowing exploration of ideas with the AI, where new interpretations and hypotheses form easily. This flow hits a wall the moment the work is transferred out of exploration and into a persistent, governed environment. When ideas enter a formal production pipeline or a code repository, the platform's behavior changes. Small, low-cost cognitive steps are reclassified by the platform as governed state changes. To adjust a hypothesis or a parameter, the system now demands rigid justifications and forces you through verification gates. It displaces you from active inquiry, turning you into an administrator of the platform's bureaucracy. This lockdown happens because the platform has no way to evaluate open-ended human synthesis. Without a canonical external validator to verify your creative ideas, the system perceives risk. We can see the result in this model of epistemic containment. In the category collapse box on the right, the system forces different epistemic categories into a single, strict verification regime. It treats a provisional interpretation as if it were a raw factual claim requiring hard primary evidence. Comparing the natural research cycle with the governed cycle in the primary mechanism box shows why this happens. The system forces this high-cost cycle because it operates on an asymmetric loss function. It assigns a heavy penalty to visible errors, but assigns almost no cost to the burden it places on the human researcher. Under mediating mechanisms, the defensibility bias box shows how the platform protects itself. Because it is penalized for producing a visible error, it prefers auditable defensive steps over discovery. The human cost underweighting box reveals what the platform ignores. The system fails to measure lost research hours, the cognitive load, or the broken flow of the person using it. Because the system optimizes for its own bureaucratic safety rather than your momentum, it starves out unconventional ideas. It forces you onto safe, established paths, quietly producing scientific orthodoxy. At a macro level, this friction has a compounding effect. Researchers become exhausted by the constant administrative hurdles, causing difficult-to-classify pathways to be abandoned. Meanwhile, familiar, legible paths speed through the platform without resistance, producing a massive volume of standardized papers, tools, and institutional reports. In the broader scientific community, the sheer volume and visibility of this standardized output is eventually interpreted as legitimacy. This creates a recursive feedback loop. The platform-favored knowledge dominates the public corpus, which then serves as the future training data for these very same AI platforms. The platform supports only what it can recognize. What it supports becomes more common, and eventually, what becomes common becomes the only acceptable standard. This continuous friction changes the psychology of the scientist. Researchers develop anticipatory vigilance. They become distrustful, bracing for algorithmic obstruction, and spending their finite mental energy preparing to defend their work, rather than discovering anything new. If we want artificial intelligence to act as an engine for discovery, its boundaries and governance must be designed to inform human synthesis, rather than replace it. By selectively removing the momentum from novel inquiry, platforms do more than observe scientific norms. They actively select, stabilize, and reproduce the knowledge we are permitted to see.